method is kind of a general outline or rules to follow to try and solve a problem. And what I want you to understand is it's not something that you're just going to use in science. It's also something that most of us use in our daily lives without ever really thinking about it. The scientific method is a series of 5 steps that you use to ask a question or to solve a problem. It's not really a strict set of steps. Sometimes when you get into older classes in high school, they might add some steps or they might change some steps around. And it's also kind of revolving. So sometimes by the time you get to step 5, you might find that that leads you back to another question and leads you back to step 1. It's also very flexible. You might discover something along the way that makes you decide you need to go back and rethink what you initially thought was going on. The first step of the scientific method is that you would ask a question. That question could be based on many things, but generally it's observations that you make. Most of us get up every morning and we probably ask the question, I wonder what I should wear today. So most of you start out your day on step 1 of the scientific method. You ask what you're going to wear today, and then you've got to try and figure out, is it something that could be measured or is there some information that I can collect? Scientists, like I said, base their question on observations, generally from your surroundings or something that's happening in your life. When you do a scientific experiment, it generally needs to be something that you can collect data on and measure the information. Another example, other than what could I wear today or what should I wear today, might be which kind of color car gets hotter on the inside on a sunny day. Step 2 of the scientific method is for you to form a hypothesis. So in the morning when you get up and you decide what you need to wear that day, you might make the hypothesis, it was really hot out yesterday. I think it's probably going to be hot out again today, so I'm going to go ahead and put on some shorts. So I think that I should wear shorts. I'm taking an educated guess to make my hypothesis. I'm taking an educated guess based on some prior knowledge. And my prior knowledge was it was hot yesterday. Generally when it's hot one day, it's probably hot again the next day. So this is what I think I'm going to do. Lots of times when we make a hypothesis like this, it's also called an inference. But again, you need to base that on evidence. You're not just pulling it out of a hat somewhere. And it's what you think is going to happen. So when you make a hypothesis, for example, on the color of the car, you might think that if the color of the car is closer to black, because many of us know that black seems to get hotter, then the heat inside the car might be hotter because we think that the black is going to absorb the heat. It's also like when I woke up and decided, what should I wear today? I think that I should wear shorts because it was hot out yesterday. Later in this class, we'll talk about how to write a hypothesis, but some good general words to use for writing a hypothesis. If I do this or that, whatever, if I increase or decrease the amount of something, then I think that something else will increase or decrease because. So an example of how we might write that is, I think if I increase the amount of cat food that I give my cat, then my cat's weight will increase because I think she will eat more and not burn as many calories. So I think if it is going to be hot outside today because it was yesterday, then I should wear the fewest clothes that I can so I'm not too hot. But of course it would be appropriate to wear shorts maybe and a tank top. The next step of the scientific method is that you should test out your hypothesis. When you're doing this, you're gathering evidence that can be used to prove that your hypothesis is supported by the data or not supported by the data. So you set up an experiment. For something like what should I wear today, your experiment might be as simple as putting on the shorts and the tank top and stepping outside to see if you're going to be warm enough, or if watching the weather, if they say it's going to be hot, or trying to figure out if you might need to add a jacket to it because it's going to be hot later. When you collect data and gather your evidence, it's kind of like we talked about memory earlier. People are going to want to have proof for whatever it is that you're testing so that you can prove what you're saying. So a good way to organize your information is to use a data table so that you can make sure your results are recorded. This allows you to have evidence if anybody asks questions later. You also want to make sure that you have repeatable information or a repeatable test. Here's an example of a data table that you might have collected the information on the car color with the heat. After you've collected your information or done your experiment, you analyze your results. So if you've stepped outside and you've decided, yep, it's pretty warm out here, I'm comfortable in my shorts and my tank top, you're analyzing and deciding what's my conclusion. So you're analyzing, am I warm enough? If I am, these shorts are going to be fine for today. Boy, if I'm cold, I might need a jacket or I might need to change. So you look at the results or the data, for example, the data table on the last slide, and you decide what they're telling you about your question. For some things, maybe like our car experiment, this may include you making a graph, and the whole purpose of a graph is for you to pick out patterns and study patterns so that you can make the best decision about what your conclusion is for the information. Here's an example of a graph that you might create. For an example, the graph on our car experiment, and it shows the temperatures of each car. Notice that this has a title, each axis has a label, and then my key didn't work out just right, so my key's in words, but the blue bar was the white car, the green bar was the light blue car, and the yellow bar was the black car. And as I'm analyzing this, my hypothesis had been that I thought that the black car would get the hottest inside. If this was true data that I had actually collected, I would be able to then make a conclusion after I analyzed my data. And the pattern was that the yellow bar, the black car, got warmer and warmer and was the warmest of the cars at the end of the day or at the end of the data collection period at 3 o'clock. Step 5 of the scientific method is that we form a conclusion. So whether we conclude, yes, we're going to wear shorts today, yes, we're going to wear shorts with a jacket, or boy, it's still going to be too cold, I think I better put on a t-shirt with my shorts or switch into jeans instead. You're making a conclusion. Sometimes making a conclusion leads us to asking more questions. Maybe your experiment was inconclusive. Maybe the data didn't show what you thought it was going to. That's okay. You're not going to go change your hypothesis. It just means that you're going to say, my hypothesis was not supported because. You can go back and you can refer to whatever data made you believe that. Or if your data did support what you thought was going to happen, you're going to make a conclusion that says, my hypothesis was supported because. You're going to refer back to your evidence and your data to explain why do you believe now that your hypothesis was true. Sometimes it might mean that you've got to do your experiment again. Maybe your results were inconclusive. Maybe on the slide, like on the slide previous to this with the cars, maybe you'd find that all of the cars gained heat at the same rate. Maybe you'd need to do more information. Other phrases to use inside of your conclusion statements, the data shows that. The relationship between the evidence proves or it disproves. And lots of times in a conclusion statement, like I said, it may lead you to asking further questions. You might end up with the statement, I wonder if I was going to do this experiment again, what might happen? Here's an example of a well-written conclusion statement. My hypothesis was supported because the black car got the hottest inside. The data shows that all of the cars started at the same temperature inside the car in the morning, but by noon, the light blue and the black car were hotter than the white car. This would seem to prove that black cars get hotter inside. Here comes the I wonder statement. I wonder if I tested a red car or a dark blue car or a green car, how those would compare. If the spinning wheel of death ends, I think I have a short quiz for you over the 5 steps of the scientific method. Actually, I just have a short video for you of the steps if this plays.
This is Science Time. have caused that change. You don't have to wonder, you just have to use your brain. The scientific method will save the day again. First you ask the question, who, what, why, when, how, or where. Then you do research, check it at the library on Foursquare. Then you make a guess, test it out with an experiment. Results will blow your mind, tell us what you find. This is science style. Science style. This is science style. Science style. This is science style. This is science style. Hypothesis is an educated guess. Based on observations, now we'll put it to the test. The scientific method is a structured way to learn. No more urban legends, you must be able to discern. That's variable, independent and dependent. Dependence, what you measure. A baseball player's 90% independence, what you change. Like is that metal or wood? Tell me which one would make it hit real good. This is science style. Science style. This is science style. Science style. This is science style. This is science style. Physicists and anthropologists, meteorologists, all you scientists, cytologists and seismologists, epidemiologists, all you scientists. That's what I said. This is science style. This is science style. This is science style.
Hope you enjoyed that nice little video that shows some of the steps of the scientific method. Quiz time. What was step 1 of the scientific method? If your answer is ask a question, you are correct. Ding, 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 ding. What is step 2 of the scientific method? If you answered form a hypothesis, you are right on. Way to go. High fives. What is step 3 of the scientific method? I know you got it. You said test your hypothesis. Good job, folks. Good job. Step 4. What is step 4? Oh, yes. Analyze your results. That might mean it's time for you to make a graph. And the last step of the scientific method, anybody? Anybody? Good job. You should form a conclusion. Thanks so much for taking time to watch this video over the steps of the scientific method. Make sure you come back with your notes all filled out so we can do an activity in class.